Today we will study the 𝓬𝓱𝓪𝓬𝓲𝓬𝓲𝓬𝓲𝓬𝓲𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬𝓬 Students, there are three factors which can change the state of which can change state of equilibrium in a reversible system. These factors which change the state of equilibrium are: number first, concentration. These are the factors. Concentration. Number second, temperature. Concentration in the system and temperature. And number third, pressure. Now, there was a scientist who was known as 𝓬𝓱𝓪𝓽𝓵. It was he gave a principle, a quantitative. It was a qualitative. He gave us a qualitative uh, principle which describes the effect of these factors on a system in equilibrium, whether the physical or chemical, which describes the effect. These 𝓬𝓱𝓪𝓽𝓵, he gave a qualitative principle which describes the effect of these factors on a system in equilibrium, whether the system is physical or chemical. So he gave a principle. The principle is, if a system in equilibrium is subjected to change of concentration, temperature, or pressure, the equilibrium shifts. Shifts in the direction that tends to undo the effect of change. This is the principle. If a system in equilibrium is subjected to change of concentration, temperature, or pressure, the equilibrium shifts in that direction that tends to undo the effect of change. Or I will write in other words, if a system in equilibrium is subjected to change in concentration, temperature, or pressure, the system adjusts itself in the direction. The system adjusts itself in such a way so as to annul the effect of change. This is the definition of the principle. If a system in equilibrium is subjected to change in concentration, temperature, or pressure, the system adjusts itself in such a way that so as to annul the effect of change. Now we will study what will happen if the concentration is changed. First, we will take the first factor, change of effect of change in concentration. You will understand the principle by first we will study effect of change in concentration. Let us take an example. I will write a hypothetical reaction. A plus B gives C plus D. This is the hypothetical. I have written a hypothetical equation. A plus B gives C plus D. That means A and B are reactants and C and D are products. Now, to this system, it is in equilibrium. Let's consider this reaction. This system is in equilibrium. If to this reaction more of A and B are added, अगर हम इसमें A और B जो रिएक्टेंट से ऐड करेंगे, रिएक्शन चल रही है, इक्विलिब्रियम में है, तो हम equilibrium, yeah, that means at that time rate of forward reaction is equal to rate of backward reaction. So at this system, if we at this stage, if we add more A and B, what will be the effect? What will be the effect at that system? So as per this Lichet-Layer principle, according to the Lichet-Layer principle जो हमें बता रहा है, he says that अब चेंज जो आपने लाई, effect of change जो आपने concentration increase की, so effect will be to the effect will be such that equilibrium shifts in the direction so as to undo the effect of change. That means आपने कंसंट्रेशन ए और बी की कंसंट्रेशन इंक्रीज की, ए और बी और डाला, दैट अकॉर्डिंग टू लीचेट-लेयर प्रिंसिपल. इसका मतलब है कि इट विल बी इफेक्ट क्या होगा, टू डिक्रीज द कंसंट्रेशन ऑफ ए एंड बी, कंसंट्रेशन ऑफ ए एंड बी, यानी इक्विलिब्रियम विल बी रीएस्टैब्लिश. यानी आपने ए एंड बी डाल दिया, कंसंट्रेशन इंक्रीज की, ऐड किया, तो द इफेक्ट, इसका इफेक्ट क्या होगा, इफेक्ट विल बी अकॉर्डिंग टू लीचेट-लेयर प्रिंसिपल टू डिक्रीज द कंसंट्रेशन, यानी ए और बी की कंसंट्रेशन अब कम होनी चाहिए. दैट हाउ इट इज पॉसिबल? दैट मीन्स concentration of A and B will decrease only if more C and D are formed. So concentration, आपने A and B add किया, so concentration as per the Lichet-Layer principle, effect will be to decrease the concentration of A and B. So concentration of A and B will decrease only when more C and D is formed. दैट मीन्स हमारी रिएक्शन तो इक्विलिब्रियम में थी, अब ए एंड बी हमने डाल दिया तो मोर सी एंड डी इज फॉर्म. दैट मीन्स इक्विलिब्रियम आपका शिफ्ट कहाँ हो गया, दैट शिफ्ट इक्विलिब्रियम शिफ्ट इन द फॉरवर्ड डायरेक्शन. दैट मीन्स आपका इक्विलिब्रियम शिफ्ट इन द फॉरवर्ड डायरेक्शन, in the forward direction. That means products are formed. इसका मतलब है आपने रिएक्शन जो थी, आपकी रिएक्शन इक्विलिब्रियम में थी, तो आपने क्या किया, यू हैव एडेड मोर ऑफ द रिएक्टेंट्स. सो एज पर द प्रिंसिपल the effect will be to decrease the concentration of the reactants. So that is only possible when more products are formed. So that means जब products दो आपका equilibrium shift कहाँ हो गया, that is forward direction, that is in the products are formed. That means the products are more products are formed. So first यहाँ से निकले हमें ये अक्स गया, if we increase the concentration of reactants increases, if the concentration of reactants is increased, so equilibrium shifts in the forward direction. That means more products are formed. Now again, if we add C and D, now I'll write this reaction in C and D. तो आपके पास C and D products है, तो if we increase the concentration of C and D, we bring C and D and add to this reaction, to the system. So according to Lichet-Layer's principle, the effect will be decrease the concentration of C and D. That means C and D कैसे कम होगा, that means if reaction will take place in the backward direction. That means equilibrium shift C and D will decrease only when A and B are formed. That equilibrium will shift in the backward direction. So if we increase the concentration of products, concentration of C and D. So that means effect will be that more A and B will be A and B will be formed, because effect will be to change to decrease the concentration of C and D. C and जब आपने C and D डाल दिया, you have brought the change in concentration. The effect will be to decrease the concentration of C and D. That means A and B will be formed. That means reaction shifts in the backward direction. Reaction shifts in the backward direction. For example, I will explain here. If we take a reaction, hydrogen H2 plus I2 iodine gives to a hydrogen iodide. So this reaction is an equilibrium, reversible reaction. Let's study this reaction is an equilibrium. Let us take the case it is an equilibrium. So at equilibrium, when it has attained the equilibrium, so if we will add hydrogen and iodine at both the Richard layers principle, effect will be decrease the concentration of H2 and I2. So that will happen only when more HI is formed till, so equilibrium will be re-established after this, if it will be re-established later on. So if we increase concentration of hydrogen and iodine, equilibrium will shift in the forward direction. That means hydrogen iodide will be more HI will be formed till equilibrium is re-established. Again, if we add HI, अब हमारे पास रिएक्टेंट थी तो प्रोडक्ट बन गई. अब प्रोडक्ट को हमने HI लाया फॉर हाइड्रोजन आयोडाइड, इसी को ऐड किया प्रोडक्ट. तो व्हाट विल बी, सो HI मोर HI if we add hydrogen iodide. So hydrogen iodide add करने से क्या होगा, equilibrium will shift in the backward direction. That means decomposition of hydrogen iodide takes place. So if we add HI more, that means HI will decompose now, because effect will be decrease the concentration of HI. That will decrease only when it decomposes, gives hydrogen and iodine. So HI will decompose. That means reaction will shift. The equilibrium will be shift. Equilibrium will be shift in the backward direction. That is, reactants are formed. So here from we got the conclusion that if we increase concentration of reactants, equilibrium shifts in the forward direction. And if we increase the concentration of products, अगर आप products की concentration increase कर रहे हैं तो equilibrium shifts in the backward direction. ये था. For example, this we will explain experimentally. If we take, for example, ferric chloride ions plus potassium sulfocyanide gives, this reaction is equal to gives FeSCN dipositive. So ferric chloride, the color of ferric chloride is pale yellow. Potassium sulfocyanide, this is colorless. And potassium ferrosulfocyanide, now this, it is reddish brown. Students, if this is this equilibrium, this is the reaction equilibrium. If to this reaction, if we add ferric ions, that means ferric chloride or potassium sulfocyanide, these are the reactants. So what will happen? More of FeSCN, that is potassium sulfocyanide, is formed, or potassium thiocyanide. This is observed by color of the reddish brown color deepness. When we take this reactant in the reactant, we get FeCN, the reddish brown color is formed. So if we add more of Fe or more of SCN, the reddish brown color deepness, that is more of, from that we assume, we consider that is established that more of Fe ferrosulfocyanide ions are formed, which are reddish in brown. I will explain again. This is ferric chloride ions and potassium sulfocyanide ions react, give potassium ferrosulfocyanide. Now if we the reaction takes place between ferric ions and sulfocyanide ions. Now, if to this reaction more of Fe, or that means ferric chloride or potassium sulfocyanide is added, that means we add more reactant. Reddish brown color deepness, that means more of ferrosulfocyanide ions are formed. Now, that means reaction shifts in the forward direction. Again, if to this reaction, let us add potassium ferrosulfocyanide. Ferrosulfocyanide ions are added. What will happen? We already know that potassium ferrosulfocyanide is reddish brown in color. So when we जब हम इसको इसी को पोटेशियम दिस फेरोसल्फोसाइनाइड आयन डालते हैं, वो तो रेडिश ब्राउन कलर में था, लेकिन जो ही हम डालते हैं सो कलर जो है वो कम होता जाता है, रेडिश ब्राउन नहीं रहता है, दैट डिक्रीजेज, डीप जो डीप कलर होता दैट डिक्रीजेज, आपका पेल येलो कलर की तरफ जाता है. दैट मीन्स what happens, ferric ions are formed. By addition of ferrosulfocyanide ions, this reddish color decreases, it becomes less and less, that means color becomes pale yellow. That means what happens, ferrosulfocyanide, this ferric chloride color is formed, that means reactants are formed. So here when we increase the concentration of reactants, products is formed, that we get by deepening of reddish brown color. But if we add ferrosulfocyanide ions, again this reddish brown color decreases, it becomes less, it decreases, it is brownish becomes less, it turns towards the pale yellow. That means what happens, ferric ions and sulfocyanide ions are formed. So addition of reactant shifts the reaction in the forward direction, that means more of the products are formed, and addition of products shifts the direction in the backward direction, that means reactants are formed. This was the effect of change in concentration. Now let us take the effect of change in temperature. अब हम किसी रिएक्शन को, इफ इट इज इन रिएक्शन एक इक्विलिब्रियम है, इसको हम टेम्परेचर की चेंज करें. दिस इज द सेकंड फैक्टर, दैट इज इफेक्ट ऑफ चेंज इन टेम्परेचर. फॉर एग्जांपल, आई विल राइट एन इक्वेशन, N2 plus thrice H2 gives twice NH3. You know, manufacture of ammonia by Haber's process. This is the manufacture of ammonia by Haber's process. हम नाइट्रोजन और हाइड्रोजन को रिएक्ट करते हैं एंड अमोनिया बनाते हैं, एंड this reaction is del H is equal to minus 92.4 kilojoules of energy. That means I will write reaction in the second way, N2 plus thrice H2 plus gives twice NH3 plus 92.4 kilojoules of energy. You know, actually effect of temperature is studied in the exothermic and endothermic reactions. Exothermic and endothermic reaction. Effect of temperature on the system in equilibrium is studied only in exothermic and endothermic reactions. Actually, these reactions are made up of two opposing reactions. For example, N2 plus thrice H2 gives twice NH3. If we study the forward reaction, it is exothermic because 92.4 kilojoules of energy are given. But if we take it in the backward direction, that means ammonia will decompose by addition of 92, by it will absorb 92 kilos of energy, and nitrogen and hydrogen will be formed. So that means these reversible reactions are made up of two opposing reactions. That is, if forward reaction is exothermic, backward reaction will be endothermic. So I have taken this reaction. You know, N2 plus thrice H2 gives twice NH3. This reaction, formation of ammonia, this is exothermic. 92 kilojoules of energy are produced by formation of ammonia. So this is exothermic reaction. So to this exothermic reaction, you know, backward reaction will be endothermic. So if we, to this reaction at equilibrium, if we increase the temperature, what will happen? By increasing the temperature, according to the Lich principle, the reaction will shift in that direction which takes place where the heat is absorbed. You know, heat is absorbed in the backward direction. I will repeat it. We have increased the temperature in this reaction. According to Lich principle, the effect will be to in that direction the electrical equilibrium will shift in that direction, which takes place by the absorption of heat. So absorption of heat takes place in the backward direction. The ammonia absorbs heat and decomposes, gives N to N thrice H2. That means if we increase the temperature, जो equilibrium है, equilibrium shifts in backward direction. That means decomposition of ammonia takes place. Decomposition of ammonia takes place. So if we take the low temperature, now if we steady, if we increase the temperature, हमने टेम्परेचर स्टडी किया, हमने टेम्परेचर इंक्रीज किया, सो इंक्रीज यहाँ पर हमारी बैकवर्ड जो रिएक्शन है दैट टेक्स प्लेस, दैट इज अमोनिया डिकम्पोजिशन, इट एब्जॉर्ब्स हीट. सो जो ही हमने temperature increase किया, the ammonia will absorb heat and nitrogen and hydrogen, that means decomposition of ammonia will takes place. So increase in temperature shifts the equilibrium in the backward direction. So that means this reaction, decomposition of ammonia, this formation of ammonia by Haber's process, it takes place at a low temperature. So here we came conclusion, low temperature favors the reaction in forward direction if it is exothermic. That means exothermic reactions, or if the reaction is exothermic, then if we increase the low temperature हम रखें, that will favor the forward reaction. अगर endothermic है, so उसमें endothermic reactions are favored by high temperature, So for example, again we take N2 plus O2 gives twice NO. That is reaction. Del H is equal to plus 180.7. That means I will write N2 plus O2 plus 180.7 kilos of energy gives twice NO. That means forward reaction जो है, that is endothermic. So if we increase the temperature, the reaction will proceed in the forward direction, and backward reaction will proceed in the, if we take the low temperature, then the backward reaction will be forward. So we came to conclusion here that in case of, I will write first, in case of increase in concentration of any substance, favors the reaction in which it is used. That means if we increase the concentration of reactants, so equilibrium will shift. It shifts the equilibrium towards right hand side, or HS, that means in the forward direction. Increase in the concentration of products shifts the direction in the left hand side, that is backward direction is favored. Similarly, in case of second factor, that is temperature. So increase in temperature that is high temperature, shifts the reaction shifts the equilibrium in case of endothermic reaction. Increase in temperature, high temperature, shifts the equilibrium in the direction of endothermic reactions. In the endothermic, for example, you have read, if the reaction If you increase the temperature, that reaction will be favored, while absorption of heat takes place, that means endothermic reaction will be favored. And if we decrease the temperature, it will shift the direction in the it will shift the equilibrium in the direction where which takes place at the low temperature. A decrease in temperature, that means low temperature, shifts the equilibrium in the direction of exothermic reactions. जिस साइड में एक्सोथर्मिक रिएक्शन होगी वो low temperature पर फेवर होगी. So this by the two factors, increase in the concentration and temperature. These two factors we have studied in case of 𝓬𝓱𝓪𝓽𝓵𝓲𝓮 principle. Tomorrow we will study the effect of pressure.